Hello, this video is meant for Mrs. Rose's AB Calculus class, and it is on the product rule and quotient rule. The product rule says if you're taking the derivative of f of x times g of x, you take the derivative of f and multiply it by g of x, and then you add f of x times the derivative of g of x. Now we're going to put this into practice. So we want to be able to find the derivative of f of x equals 3x to the fourth times sine x. In order to do this, we're going to need to know what the derivative of sine x is. It is cosine x. So it would be a good idea if we were to label this one, say, h, and this function g, and then we're going to take the derivative of the h part using the product rule, where you bring the exponent down and multiply it by 3 to get 12, and subtract 1 from the exponent to get 3. And then we're also going to take the derivative of g of x. The derivative of sine x, as I've already said, is cosine x. Now we're going to use that product rule. So we're going to do the derivative of f times g of x plus f of x, h in this case, times g of x. And that's it. There's no reason to factor out the greatest common factor because we're just taking the derivative, we're not applying this to anything, so that's just the answer. For this one, we're going to need to take the derivative of 7x, which is easy, and then use the product rule to take the derivative of x squared times cosine x. To do this, we're going to need the derivative of cosine, and that is negative sine x. I'm going to go ahead and label this one f, x squared is f, and I'm going to label cosine as my g. Then I'm going to take the derivative of my f of x, and that's just going to be x squared. Again, I'm using the product rule. The 2 comes down as the new coefficient, and then the exponent you subtract 1. And g prime of x is obviously negative sine x. So to take the derivative of h of x, we take the derivative of 7x, which is 7, and then I'm going to use a pair of brackets. I'm going to have the derivative of f times g of x plus f of x times the derivative of g of x. This one we should simplify a little bit. We should distribute this negative sign, but when you distribute it into the x squared negative sine x, negative times negative is a positive. So our final derivative will be 7 minus 2x cosine x plus x squared sine x. Here's one of the problems you should do on your more than one way worksheet. For the first way, we're going to multiply, then use the power rule to take the derivative. So when you multiply 2x times x, you're going to get 2x squared. 2x times negative 4 is negative 8x. 1 times x is x, and 1 times negative 4 is negative 4. You combine like terms, you get 2x squared minus 7x minus 4. Using the power rule, we take the 2 from the exponent, multiply it by the 2 of the coefficient to get 4x.
Ring, ring, ring.
Sorry about that, guys. That was my phone. Anyway, we have the 4x, and then the derivative of negative 7x is negative 7, and that's all we need to do. But for the other way, we're going to use the product rule. And this second method should go in the second box under this first problem. So if we rewrite our f of x, I'm going to label 2x plus 1 my h and x minus 4 my g. And I'm going to take the derivative of h of x and the derivative of g. And then my product rule is going to be 2 times x minus 4 plus 2x plus 1 times 1. That's supposed to be a times 1. Then, our answer is 2x minus 8 plus 2x plus 1 to get 4x minus 7. So the derivatives are the same regardless of which method you use. Now we're going to look at the quotient rule. The quotient rule says that if you are taking the derivative of f of x divided by g of x, we take the derivative of f times g minus f of x times g prime of x, all over g of x squared. So the order in the numerator is the same as the product rule, but now we have a minus in the middle of the two terms, and then obviously now we have a denominator. This function, I'm going to do, my numerator is f and my denominator is g. And I'm going to take the derivative of f to get cosine x and the derivative of g to get 2x. And then my quotient rule, I'm going to have dy dx equals the derivative of sine, cosine, times the denominator minus the numerator times the derivative of the denominator, all over the denominator squared. There isn't much you can do with this. Usually we rewrite the function so that the polynomial part is in front of the trig function. And something to keep in mind is that sine of x times 2x, it does not equal sine of 2x squared. This is illegal math. To find the derivative of k of x, I'm going to make my numerator f and my denominator g. Then I'm going to take the derivative of my f of x to get 10x to the 4th plus 14x, and then my derivative of g of x to get negative sine x. So the derivative of k of x, or k prime of x, using the quotient rule, I'm going to have the derivative of f times g minus f times the derivative of g all over g squared. The only thing to really do with this one in terms of simplification is distribute that negative. But again, because you have a negative times a negative, we get a positive in the numerator. Note that you can write a square for a trig function between the letters after cos and then before the x symbol. To find the derivative of tangent x, we're going to use the trig identity that tangent is sine over cosine. And I'm going to label this cosine, sine is f and cosine is g. So our derivative of f is cosine x and our derivative of g is negative sine x. Using the quotient rule, we're going to have the derivative of sine times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. When you have cosine times cosine, that's going to be cosine squared. And when you have a negative sine x times negative sine x, that's going to be positive sine x squared all over cosine x squared. And if you remember, sine x squared plus cosine x squared is 1. So we can simplify this to 1 over cosine x, which is the same as 1 over cosine x times 1 over cosine x, which is the same as secant squared x. And for our last problem, for the more than one way, we're going to look at two ways to take the derivative of a complex fraction. The first way we're going to do is separate the fractions and then rewrite and then use the power rule. So my f of x is going to be oh, I forgot. I meant to make the denominator 2x squared. Let's change that. Okay, so we have 2x to the 5th divided by 2x squared minus 4x to the 3rd divided by 2x squared plus 7x squared divided by 2x squared minus 5x divided by 2x squared plus 3 divided by 2x squared. So I'm going to rewrite this as a simplified function where we have just x cubed minus 2x plus 7 halves minus 5 halves x to the negative 1 plus 3 halves x to the negative 2. Now I'm ready to take the derivative using power rule. I'm going to have 3x squared minus 2 plus 0, which you don't have to write, plus, because a negative times a positive is positive, 5 halves x to the negative 2 minus 3x to the negative 3rd. And I don't like negative exponents, so I'm going to rewrite it with all positive exponents. Unfortunately, we're not quite done. The final answer looks like this. And the way we get that final answer is we look at the denominator. We need to get a common denominator. So we're going to use 2x cubed as the biggest denominator. This one needs to get multiplied. Actually, see, this x is supposed to be a 2. Whatever you multiply on the bottom needs to be the same on the top. So times 2. X times x. This needs to be a 2x cubed, so 2x cubed. And this needs to be a 2x cubed times 2x cubed. So we're going to get 6x to the 5th minus 4x cubed plus 5x minus 6 all over 2x cubed. For our second way to calculate the derivative, we're going to use the quotient rule. I'm going to make my numerator g, and I'm going to make my denominator h. And again, we're making the denominator 2x squared and versus just x squared. So the first thing I'm going to need is take the derivative of g of x. So we've got 5 times 2 is 10, subtract 1. 3 times 4 is 12, subtract 1. 2 times 7 is 14, subtract 1 from the exponent, and then minus 5. The derivative of h is 4x. So for our quotient rule, the derivative is going to be the derivative of the numerator times the denominator minus the original numerator times the derivative of the denominator. And all of that is over the denominator squared. From here, it's really just algebra. We're going to multiply 2x squared times everything in the blue parentheses to get 20x to the 6th minus 24x to the 4th plus 28x cubed minus 10x squared, and then we go to the next set of parentheses and we multiply 4x times everything in the blue to get negative 8x to the 6th plus 16x to the 4th minus 28x to the 3rd plus 20x squared minus 12x, and that's all over 4x to the 4th. Okay. Well, 20x to the 6th and negative 8x to the 6th combine like terms to 12x to the 6th. And then I've got 24x to the 4th, negative 24x to the 4th, and 16x to the 4th to get negative 8x to the 4th. And then I've got positive 28x cubed, negative 28x cubed, and that's going to be 0. And then I have, let's do green, negative 10x squared, positive 20x squared to be positive 10x squared. And then my last number is just negative 12x. From here, from the numerator, I'm going to factor out the common factor, which is 2x. And then I'm left with 6x to the 5th minus 4x cubed minus 5x over 6. And that's all over 4x to the 4th. And I can reduce that denominator and numerator, 2x and 4x to the 4th, to be 2x cubed. And now we have the same exact answer both ways we solved this problem. Thanks for watching this video. As always, if you have any questions, homework, or the problems that I did on this video, please come to Kev Morning or stay after school. See you in class.